a little bit important. So despite me being kind of mean yesterday and getting all grr with you and telling you that this was bad, that we only had half of you turning it in, we still had less than half of everybody turn it in yesterday. So this week, all of the assignments and things are now an assessment. So you'll be graded on the number you turn in out of 4. That'll be your grade. So if you turn in 2, you'll get a 2 out of 4. If you turn in 3, you'll get a 3 out of 4. If you turn in 4, you'll get 4 out of 4. The videos are still up, so you can still go back and watch and redo the other ones. And it is the easiest assessment you'll ever do because you literally just have to watch what I write and write it down yourself. You will never have an easier assessment than the one you have today. So we're going to talk about the stuff for today. Some people did do the work and then didn't turn it in, so please make sure you've submitted them. Because if you haven't, then I'm not going to grade them unless I actually see that they're in. Let's go ahead and get started on today's.
I did both. I did it.
That's what you're supposed to do, is do it and turn it in. So hold on, give me just a second. I don't want to share my email. I forgot to get the sharing thing ready. Okay, so once again, just so that everybody knows where we're looking, if you go into the Google Classroom, you've got a internet is back up and running. Andy's very unhappy about it, apparently. That's a little bit harsh. Underneath the main class Zoom meeting, or over top, sorry, there's a new assignment, operations as other operations. If you click on the instructions, there's a PowerPoint. Open that up. That's where you're going to take the notes. Well, once again, you're going to have to write all the things that I write, and that's it. There's not even a homework slide on this one. So you literally get all the answers just for watching the video or being in class. So before we get going on that, let me get the actual PowerPoint up. All right. So yesterday we did kind of the most confusing day of this week, the most difficult one by quite a bit. The day before that was the easiest one by quite a bit. So today we're going to kind of middle out, and hopefully it'll be more at the level that everybody can understand, but is also a little bit of actually useful stuff. We're going to be talking about operations as other operations. So we talked about this a little bit yesterday. What exactly is an operation in math? Anybody?
Multiplying, dividing, adding, and subtracting.
Right. So multiplying, dividing, adding, subtracting, exponents, logarithms, which you probably don't even know what those are, but you get the point. Basically, anytime you're manipulating numbers. So a lot of operations in math are just shortened versions of other operations. Multiplication, for example, is just repeated addition simplified. So you probably way back in kindergarten or something, learned that multiplication is basically if I have 5 plus 5 plus 5 plus 5, what I really have there is just 4 groups of 5 or 4 times 5, right? That's what multiplication actually is. Multiplication basically tells you add 5 to itself this many times. No, you don't need to write anything down on this slide. Exponents are another example. Exponents are just repeated multiplication. We're going to look at exponents a lot more in 8th grade next year, but hopefully you guys remember that 3 cubed equals 3 times 3 times 3. That was a bad example because I used the same number. 5 cubed equals 5 times 5 times 5. So yeah, inverse operations can also be used in place of each other with some clever alterations. So we'll talk about those in a little bit, but we're kind of going to go in order of these. So let's look at the first one. This year we looked at how to subtract and add negative numbers. This is the first slide you're going to have stuff to actually write down. This is something we've already done, so this shouldn't be too hard for you. But what I want you to do is change the sign of our second number so that we can write this as the opposite operation. So here we have 52 minus 33. I want to make this into an addition problem. So we're going to 52 plus what? Oops. What am I going to write, or what am I going to add to 52 to get the same thing as 52 minus 33?
Negative 33.
Yep, exactly. Negative 33. So we can just put in parentheses, negative 33. So that's what problem that we actually, this is something we did earlier in the year. This should look pretty familiar. How about if I want to change the operation on 26 plus negative 15? I'm going to make it 26 minus, and then what am I going to subtract? Yeah, it's just going to be 26 minus 15. And how about 32 minus negative 12? What am I going to switch that one to? Correct. It's going to be 32 plus 12. Right. So these ones are pretty simple. Hopefully you all understand how to do these already. The first one is something we've done already a bunch this year. The second one is just kind of a shortened version or going backwards from the first one. And then this third one is something that hopefully everybody knows. When you have a negative symbol next to a negative symbol or a minus next to a negative, all you have to do is add them together. Okay, any questions before we go on to something a little bit more complicated?
Can you hold it? I'm gonna be right back.
How long am I supposed to hold it?
Not.
What?
Okay, I'll let you catch up. So we talked about adjacent signs already a couple of times. So for instance, when we had, just in the last problem, we had this, whoops, why isn't it going backwards? So in the last problem, we had this 32 minus 12. So we had a minus next to a minus. What we can do whenever we see two minuses together, we can think of them as a plus. So really, if you think about it with symbols, now obviously these problems down here aren't actual real math problems. You would never write a problem like this, but it gives us an idea of how to simplify the signs. Personally, the way I like to think about it is each line is like half of a positive. So the first one is a negative. If you have a second one, it makes a positive. Then another one will make another negative, and then another one will make another positive. So all we have to do here, we can ignore the pluses altogether. They can just kind of go away. They don't matter. So all we have to do is look at the minuses. Yeah, Jay, I'm not going to wait around for you to go to the bathroom. Sorry. So all we have to do is look at the minuses. And really what you can do is count them, but we'll go ahead and go through it step by step. So we can ignore this positive. We can ignore this positive. You don't have to write crossing out positives because I don't know how you do that. But we have a positive here, and then we have a negative left. So again, we can ignore the positives, and we're left with just a minus. So this simplifies down to just 5 minus 3.
Wait. Wait. I can only see like some things at the very top, but nothing else.
Okay.
So we're supposed to write down 5 minus 3?
Yes. So the part you actually want to write down here is 5 minus 3. So let's look at the second one. What do we do with these two minuses?
Positive.
Yep. What about this minus and this minus? Those will form together to make another positive. This minus and this minus will be another positive. And then we have one minus left over. So overall, is this positive or negative? Or a plus or a minus?
Minus.
Yep. Overall,
Minus.
this is a minus. That is correct. So it's going to be 23.
Barney, yeah. Sorry, I thought I was muted.
That's okay. All right. And then for the last one, we have.
Question.
What's your question?
But like, oh, wait, I'm confused. So, why is there more than one negative sign?
So like I said, these aren't necessarily real problems. The idea here is just to learn how to combine and simplify these operations. So this is not how you would write an addition or a subtraction problem, but we can use this trick to simplify even ridiculously long ones like this. So all you're doing is looking for pairs of minuses that you can combine into a plus. And then the pluses you can ignore. Where this is actually useful is if you're doing multiplications of negatives. So if I have -3 times -3 times +4 times -3, it's basically the same thing as this. You're just looking for a one negative gives me a plus, and then I have one negative left over. So my overall would be negative. It's the same basic idea. We're just doing it with the pluses and minuses instead of doing multiplication because I wanted to go step by step. But I do see why this is a little bit confusing if you look at it by itself. So the last one, let's see. We've got one minus and one minus, so we can combine those into a plus. So overall, we have 42 plus 12. And then we need to look at our 12s and our 15. So in between this one, we have 1, 2. Those combine, these combine, and these combine. So it's plus, plus, and plus. So overall, this is just a plus. Haley, remember this is an assessment, so probably don't want to just not do it. Okay, so that's adjacent signs. Like I said, the place where this is actually useful is in multiplication. But again, all you have to do is look for the negatives, combine every pair of negatives combines into a positive, and then, look for how many you have left over. All right. The next thing I want to look at is how to switch multiplication and division. So what we can do with multiplication and division is we can invert them using fractions. So for example, 10 times 32, we can rewrite as 10 divided by the fraction 1 over 32. Generally speaking, though, it's a lot more useful to go the other way. So the only ones we're going to look at as examples are going this way. So how could I rewrite 43 divided by 13 as a multiplication problem? 43 times what? Here, I'll use x's since that's what you'll have to type.
13 over 1.
Not 13 over 1.
1 over 13.
Yep, 1 over 13.
Wait, do we have to write this? Because I can only see the 5 minus 3, 23 minus 17, and 42 plus 12 plus 15.
Move to the next slide, Jay.
It should, yeah, you should be on the next slide.
Wait, is it 12 plus 15 or minus 15? On the last slide.
It's plus 15. So we're on the next slide now, Jay. Yeah. So now we have 112 divided by 52. How would we rewrite that one as a multiplication? We'd have 112 times what?
1 to 52.
Yep, 1 over 52. And what about 2,468 divided by 4?
2,468 divided by 1 over 4.
Times 1 over 4, but yeah. Times 1 over 4. Now you might be thinking, Cleary, that's not useful. That doesn't help us at all. But I'm going to show you why it does. So here are some ridiculously long problems with multiplication and division. What we're going to do is, instead of dividing these all out individually, is write this whole thing as a fraction. Now, on your slides, you won't be able to actually write this out. So what you can do when you're typing this one is do a slash and then just put the numbers in parentheses. So,
Clary,
yes.
can you slow down a little bit?
Oh, yep, sure. Did you miss stuff here?
Miss the 112 and the 52 and the 2,468 divided by 4.
Look at the Zoom thing.
It might be lagging for him.
I know, it's just not moving fast enough.
So give it a second.
Oh,
I'll let you guys.
Sorry.
I'll let you guys have a chance to write it down. Why did I mark Kate as not here?
I don't know.
Because Kate is definitely here. I got it fixed.
Wait, whoa. Where'd the other slide go?
You told me to move back.
No, I didn't. I'm still on the multiplication and division one. Thank you.
Jay, that's the one we're on.
Okay, I think Jay is way behind. Okay, well, I'm going to move forward. If you miss something, I will help you get it caught up at the end of class. So try to stay along if you can.
I got that.
So here's what I'm going to do. I'm going to write this out on the left side in the way that's the most useful. And then on the right, I'll write what you can actually type it in your own document. So here what we're looking for is all the numbers that are multiplied can go on top and all the numbers that are divided can go on bottom. The reason for this is because effectively what we're doing here, right, is if we have 13 times 22 times 1 over 4 times 16 times 1 over 11 times 12 times 1 over 52, all of those fractions are just going to go to the bottom. So we have 13 on top, we have 22 on top, we have 4 on bottom, 16 is on top, 11 is on bottom, 12 is on top, and 52 is on bottom.
You could technically do that if you had really good handwriting.
What? That's true. You
There's a
could.
scribble thing on the Google slide.
That is true. I wouldn't do that. What I would do is, if I were you, you can do 13 times 22 times 16 times 12, all in parentheses, divided by 4 times 11 times 52. Now, writing out problems like this, again, these are not kinds of problems that you see a lot in 7th grade math. And in general, you wouldn't see it exactly like this in algebra, but you're going to have problems similar where you have fractions like this. And one of the nice things is we can start doing some canceling out as we go. So like, for instance, 4 and 16, I can cancel this to 4 over 1. 22 and 11, I can cancel this to 2 over 1. And then the 52 would actually cancel out with the 4 and the 13. So we can solve this really quick down to 24. But that's not necessarily the thing you need to know right now.
I figured out a way to do it like the fraction. You just have to put a line underneath them.
Oh, that's
Use a
true. You
line
could just underline them and then do another line. Or even just draw a line in with the little slide thing. So there are ways you could write it. But again, this is just, I just wanted to show you all why this actually is useful. So it's not just you doing things for no reason. So
It just put it in. Can you type it? Do we have to type the thing that are these?
but Jay, like I said, just type the stuff that's over
Yes,
parentheses
you type
on the right.
you type it in parentheses, Jay. You use the
Yep.
parentheses.
Yep. Okay, now on this second problem, what I want to do is I'm going to draw out a fraction line like this. I want you guys to tell me which numbers go on top and which ones go on bottom. So does 33 go on the top or the bottom?
Top.
Top. Does 75 go on the top or the bottom?
Bottom.
Top.
I'm getting 50-50 on this one. It is
Top.
top. Yep, because it's multiplication, it goes on top. What about the 11?
Bottom.
Down.
Yep. How about the 2?
Top.
Top. What about the 9?
Bottom.
Bottom.
Bottom, good. 7?
Top.
Top.
5?
Bottom.
Bottom.
27?
Bottom.
Slow down,
And
slow
9.
down, slow down.
Top.
So basically all we did is any numbers that are followed by, or that are multiplied in this are going to go on top. Any numbers that are divided are going to go on bottom. And again, this lets us do a lot of our canceling out. So we see that there's a 9 on top and a 9 on bottom. We can just cancel those right away. We've got an 11 and a 33, which will simplify to 3 over 1. We've got a 5 and a 75, which will reduce to 15 and 1. And then we've got this and this, which can cancel to 5 over 9. And then this and this, which can cancel to 1 and 3.
Can you
So you
put
end
it in
up with-
parentheses?
Yeah, I will in just a second. So you end up with 70 over 3. But the point is, you can use this to get through this multiplication problem a lot faster without actually having to do, 33 times 75 and then divide that by 11 and then times 2 and then blah, 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 blah. Now, admittedly, typing it into a calculator would probably still be easiest, but that's okay. All right, so in parentheses, this would look like this. 33 times 75 times 2 times 7 times 9, all divided by 11, in parentheses, times 9 times 5 times 27. So that's what those ones look like. So once again, this is the kind of stuff that is going to be really, really helpful in future classes. It's just a different way of thinking about how you can multiply and divide things. It might not necessarily be helpful with what you're doing this year. And I'll give you all a second to write it down because this is a lot of numbers. I think we only have 2 slides left up.
We only have one.
Oh, only one. Okay. All right. Do you need more time or are we ready for the last slide?
Ready for the last slide?
Need more time?
No, wait.
Finish
Wait.
typing.
Okay,
Wait.
I'll wait. It's like 3 people that are.
Tell me if I got this right. Okay. In parentheses, 33 times 75 times 2 times 7 times 9
Mhm.
divide over or divided by, I don't know, slash 11 times 9 times 5 times 27.
Yep, that sounds right to me.
Yes.
All right. Are we ready?
No.
Yes.
But you just said you got it right.
Yes. I know, but I need to put the answer.
Okay. You don't actually need the answer. I don't care if you have this part. I was just
I was
showing
gonna say. I was gonna say.
Okay.
Wait. We need to do the answer.
you.
Ooh,
No, you do not need to do the answer.
Yeah. That was
Okay,
Okay.
now you can go.
So this one, I just want to go back to that multiplication and addition. We're actually going to use this a little bit tomorrow. So this is what I wanted to end on. So how would I write 3 times 7 as an addition problem? Can anybody tell me? Since some of you are saying you're done already.
I can.
Okay, what is it, Kaylee?
It's 3 plus 7, I think. I mean, no. 7 plus 7 plus 7.
Yep.
Boom.
7 plus 7 plus 7. So we have 3
Yes.
7s that we add together. Okay, what is 5 plus 5 plus 5 plus 5 plus 5 plus 5 plus
5
5?
times 8.
It is 5 times 8. So do be careful counting these out, but there are 8 of them. Since there are 8 of them, that is effectively 5 times 8. And what about 4 times 12? Right, 12 plus 12 plus 12 plus 12. Now, I just want to do a little bit of a preview of tomorrow. This is all we're doing today. So this is just kind of a separate question. If I was going to write 4 times x as an addition problem, what would it be?
X
Um,
plus X
X,
plus X.
X plus X plus X.
X
Yep,
plus X
exactly.
plus X plus X.
So this is something that's going to be important tomorrow. I will show you why. It will make more sense when we get to it. But hopefully you all see how this works. So
Done.
4 times x goes to x plus x plus x plus x. All right,
Can you
that's all we
go
got for
back to
today.
Slide 4.
Yes, I can. Give me a second to close out class, and then I'll go back to whatever you guys need. So please remember that the first 2 of these this week need to be turned in as well. That's multiplying by tens and numbers as operations. Make sure you get both of those in because they will count as part of this assessment. But otherwise, you guys have no homework for today. You are good to go. Have a good rest of your day, and I will see you.
Bye.